Hey guys, so just a quick video for today. I wanted to introduce you a little bit to units and unit conversions. So the first thing I want to talk about is fundamental units. All right, now it's important in science because we're trying to work with people in other communities and other countries and things like that when we're sharing information that we're very consistent with the units that we use. All right, so there are 7 fundamental units in physics that we work with. Not in physics, just in science in general, right? The units that we work with, generally speaking, are length, mass, time, quantity or number, luminous intensity, current, and of course temperature. Okay, now these are what we call fundamental quantities. All right, now any other quantity in physics, chemistry, biology, whatever, we should be able to write in terms of these 7. These are the 7 things that we can measure, and then everything else, energy, work, force, all of these other things, electrical potential, all of those can use these, can be built out of these. Now, for length, we usually use meters, okay? For mass, we use kilograms. Now this one's a little bit different because it's not just the simple grams, it is kilograms for mass. That's consistent everywhere. You've got time, which of course is seconds. Quantity, which is moles, right? Which a mole, 1 mole equals 6.02 times 10 to the 23rd of anything. You can have a mole of atoms, but you can also have a mole of apples or a mole of naked mole rats or, whatever you want. So you can have a mole of anything. It just means that many of that thing. That'd be a lot of naked mole rats. You've got the luminous intensity, which is candelas. You've got the current, which is in amperes, and some students say, well, isn't charge more fundamental than current? The answer is actually no. Current is much easier to measure than charge, especially back in the days. Current was much, much easier to measure than an individual charge, and so therefore current was the fundamental. You may know that current is charge over time, but instead charge is current times time. Okay, so charge we get from amperes. Amperes is current, and the temperature, of course, is not Celsius, it's Kelvin, but we can change from Kelvin to Celsius back and forth. We'll talk more about that as time goes on, but I think you did that, most of you, in chemistry already. Okay, so at this point, what I'd like to do is go through a couple of examples where we are going to work on how we, I didn't want that to happen. We're going to go through a couple of examples on how to convert between. Now, I know that you may be very comfortable with conversions already, but I want to show you a method, a way of doing it that may be helpful when conversions get a little bit more complex. This method is something called dimensional analysis. Okay, now sometimes it's called the train tracks method, but I'm going to work through the 4 questions up above, and what we're going to do for all 4 of these up above is we're going to turn these into what we call SI, or International System, Sistema Internacional, or I don't know how to pronounce it, but we're going to turn it into the SI units. Okay, now the SI units are the ones that we've written down here. Okay, there are all of these, the English system or imperial system has similar units as well, but we're not going to worry about those too much right now. We may need to do conversions at times, but those are not things that you need to have memorized. They're just things that we need to be able to work with possibly at times. All right, so let's go ahead and work through each of these. The first one's pretty simple, pretty straightforward. It says we start with the distance of a marathon, which is 42.4 kilometers. We want to turn that into SI units. And notice that this is a distance, which means that we want length, which needs to be in meters. Now, of course, many of you could probably already write the answer, but my goal here is to teach you a process, the process of dimensional analysis. So what we're going to do is we're going to start with 42.4 kilometers. Okay, now in dimensional analysis, you create this table, which some people like to call the train tracks, but really it's just a table. Really what it is just a whole bunch of fractions, and you might be able to imagine it as being fractions, but for some people this is just a way of organizing it. Okay, now at this point, what do I want to do with those kilometers? Well, I want those kilometers to turn into meters. Okay, so that's this dimensional analysis. I want the kilometers to turn into meters. But when that happens, I really need the kilometers to cancel out. So the only way I'm going to get the kilometers to cancel out is if I have kilometers down here on the bottom. Okay, so now at this point, I'm going to go ahead and put in the numbers for meters and kilometers. Now, I know some people have a hard time when they have to remember, am I supposed to be dividing by 100 or multiplying by 100 or by 1,000 or whatever else? Well, here, all you need is the numbers, right? As long as you put the numbers in the right place, because I've already put the units where they need to be, it has nothing to do with multiplying and dividing. Watch this. We know that 1 kilometer, here it is right here in my prefixes. This will be given to you. You don't have to have these memorized. I'll give that to you. Okay, 1 kilometer, K means 10 to the third or 1,000 of the original thing. Or in other words, 1 kilometer is 1,000 meters, just like that. Okay, if I knew what 1 meter was and the number of kilometers in that, I could have done that as well, and hopefully we'll see that in some of these other examples. But that's it. There's 1 kilometer, 1,000 meters. I just put the numbers where the units already are. Okay, and now at this point, I can just go ahead and do the mathematics. So what I do is anything on the top gets multiplied. So anything, if I have I may end up. This is why this is called train tracks. I may end up with multiple terms here. Multiply everything on the top. And then you divide by anything that's on the bottom. And in this case, it's just 1, so it's not a big deal. And so in this case, I just multiply the two things on the top, and I get 42400 meters, 42,400. If I were to write that in scientific notation, it would be 4.24 times 10 to the 4th meters, and that would be an appropriate answer in SI units because I converted it to meters in scientific notation. Now, most of the time we're going to deal with things just in 3 significant figures. You can see I dropped off the last 2 zeros there. They're not really all that important. I'm just going to write it in 3 sig figs. Most of the time our accuracy, or actually more correctly, our precision is only going to be within about that much anyway, 3 sig figs. All right, let's go ahead and look at question number 2. So question number 2 gives us the mass of a ladybug, which is 20 milligrams. All right, now I want to turn that into SI units. Now SI units for mass, for grams, is actually not grams, it's kilograms. You can see down here. So I want to turn that kilograms into, that milligrams into kilograms. Now, unfortunately, I don't have a conversion straight from milligrams to kilograms. So this is going to be a multi-step question. Here I'm going to create my dimensional analysis, my train tracks. So the first thing I want to do is I want to take my milligrams and turn it into grams because I know how to do that. Not only do I want to turn into grams, I want the milligrams to cancel out eventually. So now I can look at this and say, well, how do I turn grams into milligrams? Well, if we look at my prefixes over here, we can see the milligrams over here on the left-hand side. What that means is that there are 10 to the negative 3rd grams in 1 milligram, right? This is telling us how many of the original thing there are in the mg, right? Just like here, there were 10 to the 3rd meters in 1 kilometer, right? And so that's always what it is. It's this thing over here of 1 of these. All right, so we've got that. Next up, I've already now, you can see that when I do this, the milligrams are going to cancel out. And so now I'm going to be in grams. So now I want to turn it into kilograms. So the grams needs to turn into kilograms, right? Now, of course, I want the grams to cancel out, so I'm going to put the grams on the bottom. And then I can do the same thing, essentially, that I did before, is that look at my kilograms over here, and I recognize that 1 kilogram is 1,000 grams. And again, I didn't have to worry about, do I multiply, do I divide? I'm just saying I put the units where the units are supposed to be, and then I put the numbers right where they're supposed to be. All right? Now, everything's set up. I just got to do the math. So, everything on the top, 20 times 10 to the negative third times 1, multiply everything on the top, and then I'm going to divide by everything on the bottom. So whatever I get there, I'm going to divide by 1, and then I'll divide it by 1,000. And so what I should get is 0.000, so it should end up going 1, 2, 3, and then 3 more, 0.2 kilograms. And that is going to be my SI units. Okay, again, if I want to write that in scientific notation, 3 sig figs, I would go 2.00 times 10 to the 1, 2, 3, 4, 5, so negative fifth kilograms. I know it's going to be a negative because I don't want to be showing that I have 20,000 kilograms here, right, or 200,000 kilograms. I want to make sure that it's a small number. That's why I know it's got to be a negative for my power. I'm always going to check that and think about that to make sure that my answer makes sense. All right, very good. So that's question number 3. Okay, number 2. Let's move on to question number 3. So in question number 3, it's the speed. So we're getting progressively more complex here. The early ones, obviously, you could do without this process, but I want you to see how we use the process of dimensional analysis to do these questions. All right, so we've got the speed of a person walking 3.1 miles per hour, given that there are 1.60 kilometers in 1 mile. All right, so here we go. Again, now this one has something per hour, right? So we're going to rewrite this as 3.1 miles. And then instead of putting miles per hour on the top, I'm going to put the hours on the bottom here. Okay, now the first thing that I want to do is I'm going to go ahead and turn the miles into, I'm going to change the top first. We're going to turn the miles into kilometers. And that was given to me here in the question, right? 1 mile is 1.6 kilometers. I don't have to worry about, do I need to multiply or divide, because I know the miles need to turn to kilometers, and I know I need the miles to cancel out. Now, what it says up here is that there are 1.6 kilometers in 1 mile. And so there you go. You just write it down, and you've got it. So now it's going to be in kilometers, but kilometers is not SI units, so I need to turn the kilometers into meters. Okay, so we're going to turn the kilometers into meters here. And in order to do that, I need the kilometers to cancel out. And again, I know that there are 1,000 meters in 1 kilometer. And you'll notice that the kilometers then will cancel out, leaving me with the meters. So the meters is correct, but the hours on the bottom are not correct. So now I got to turn the hours into seconds, right? So first, I may not know how many seconds there are in an hour. Maybe you do, maybe you don't. But I do know how many minutes there are in an hour. So the first thing I'm going to do is I'm going to turn the hours into minutes. And I want the hours to cancel out. So I'm going to put an hours on the top. Hours will turn into minutes. There are 60 minutes in 1 hour. Now I want the minutes to turn into seconds. The nice thing about this is I haven't even done any math yet, right? All I'm doing is worrying about the units, the dimensions. That's why this is called dimensional analysis. Again, I want the minutes to one step at a time. Get the minutes to cancel out. And so therefore, I know there are 60 seconds in 1 minute. And now I'm done. That's it, right? I've got the hours turned into seconds. The seconds are left. All the other units cancel out. And I got the distance on the top turned into meters. So now I can just go across the top and I can go 3.1 times 1.6 times 1,000 times 1 times 1 divided by 60 divided by 60, right? Multiply everything on the top, divide by the stuff on the bottom, and I get an answer of 1.38, and I'm going to round it, and this is meters per second. No problem, right? It becomes much easier if you look at it step by step rather than trying to do everything at once, all right? Now, this last one is kind of an interesting example because it maybe has some physics in it that we don't even understand yet. And you know what? That's okay, because we don't need to understand all the physics if we're using dimensional analysis. Now, understanding the physics is great, and I hope that eventually you'll get to the point where you do understand this physics. But if you don't, you can still answer a lot of questions. This is some questions very much like this. All right? So what we're saying is that we have 1 mole of uranium can generate 1.8 times 10 to the 10th kilojoules of energy. And we want to know how many joules per atom are produced. Okay, so this question is going to be a little bit different. I'm not going to start exactly the same. The reason being is that in the other ones it was clear. The first one I wanted to turn into meters, right? So I wanted to have the meters on the top. The second one I wanted to turn into kilograms, so I had the kilograms on the top. The next one I wanted to turn into, I had a speed, and I wanted to turn the speed into SI, and so the speed was meters per second. So I knew I wanted the distance on the top and the time on the bottom, so I put the distance miles on the top and hours on the bottom. This one's a little bit harder, but this one the question says how many joules per atom. Okay, now I may not know what a J is. I may not have any idea what joules are. Okay, well I do, but maybe you don't at this point, and that's fine. We can still answer this question because we know in the end that we want joules on the top and atoms on the bottom. Okay, so that's our goal. Now what is given to us in the beginning? It says 1 mole of uranium has 1.8 times 10 to the 10th kilojoules of energy. Now you'll see that the joule thing is here up on the top. So I want to make sure that the joule thing is on the top. So I'm going to put that one on the top, the 1.8 times 10 to the 10th kilojoules. That's going to be up on the top. And that comes from 1 mole of uranium, just like that. Okay, now I did that solely based off of this idea that the answer needs to have the joules, whatever that thing is on the top, it's energy by the way, and then the atoms, whatever the other thing is on the bottom, but I'm making this connection between the kilojoules and the joules, okay? So now I'm gonna make a conversion, right? I want the kilojoules to turn into joules, I know, because that's what I want in the end, and I want the kilojoules to cancel out, just like this. And so I know, due to my chart up there, that 1 kilojoule has 1,000 joules, just like that. So I'm now in joules. So now I need to go from 1 mole of uranium to atoms, okay? And we know that 1 mole of anything is 6.02 times 10 to the 23rd. So I want to turn the moles into atoms, okay? So I'm going to have atoms here on the bottom. And then I want the moles to cancel out, so I'm going to put it on the top so that the one on the bottom and the one on the top cancel out. And then I'm going to put the numbers in. I know that 1 mole is the same thing as 6.02 times 10 to the 23rd atoms. And so at this point, I've got everything ready. You'll notice that at this point, the units on the top, these guys canceled out, leaving me with just the joules. And on the bottom, I got moles and kilojoules cancel out, leaving me with just atoms, and that is exactly the units that I need here. I'm just dealing with the dimensional analysis, just dealing with the units. So at this point, I can multiply my 1.8 times 10 to the 10th, multiply that by 1,000, divide by anything on the bottom. Again, you don't have to worry about the ones, but the 6.02 times 10 to the 23rd is good. And we should get our answer when we do that, which is 2.99 times 10 to the negative 11th joules per atom. All right, and we don't know what that means, but we were able to get the answer. All right, so there you go. That's this video. I hope that's helpful. I'd like for you to go try some on your own.